Greetings everyone. Welcome to another Let's Tinker edition of the DC Current. I'm your host, Damon Caskey. This one actually comes by request. I am going to explain how I achieved the eye blink effect in my Quests of Queen Anne original IP project. If you are paying attention, I know it's kind of hard to see in a video, you may notice the character Valis here is blinking his eyes occasionally. Now that's probably doesn't really seem like a big deal on its own. I mean, we can hop over here to let me move forward and pause the action here. There we go. I mean, I have a King of Fighters 2001, fairly well-known professional game, and as you can see, it includes eye blinking. So, what's so special about that, right? Well, the difference is, if you pay attention, that eye blink effect is only baked into the animations, right? So while the character is walking, if there's any eye blinking at all, it's going to be right in with the animation cycles. But it's not, it's just when she's crouching. Whereas, if we come over to the Quests of Queen Anne project, yours truly, if you pay attention, Valis's eye blink is completely divorced from his animation. So he's walking and he still occasionally blinks. He's standing, occasionally blinks, and the eye blink is randomized somewhat. The blink itself has a randomized duration. The time between blinks is also randomized within, of course, a specific timetable. So it just kind of makes it a little more organic. Let's see if I can catch him blinking in a jump here. Just to well, there we go. So you can see it has absolutely nothing to do with the animation at all. Well, that shouldn't be possible, right? Because this is a sprite-based game, and you can't change sprites in the middle of a runtime, but you can change colors and palettes. And we've talked about smart paletting before, but I haven't really quite demonstrated how that works, what you can do with it. Well, that is how this blinking effect is achieved. So I want you to pay attention to Valis's colors here. You know, he's got the red tabard and the white breeches and the armor and the little and all that. But if we come over here to production, well, as I joked before, it looks like he lost a fight with Rainbow Dash. That is because Valis is using a smart palette. So just about everything that you see here is color separated. That's why his brown boots here are a raspberry. The red tabard is actually this sort of, I guess, just blue. The straps are periwinkle. And in a previous tutorial, I was talking about how I was going through and reseparating even the pauldron, which accidentally shares some colors with his boot trims. I haven't fixed this sprite yet, but it still works as an example because it is mostly separated. What that means is we can load a palette when the engine starts or when the character comes on screen that overrides this default. Because just because you have a set of colors that are within images, that doesn't mean that's what the image has to show on screen. That doesn't mean it has to be your default and then you switch to alternates later. You can switch to an alternate palette right as your base main palette. And I'm using the word palette a whole lot, but don't worry, I'm going to explain as we go along. First, I want to show what it looks like in Photoshop. Let me change this palette, or open the palette, and you can see these are all of the colors in the production sprite. Okay, so all I have to do is load. So we have Valis's base palette. If I were to load that, then you'll see, other than the black, which Photoshop sticks as a tail end to empty colors, it is identical and nothing changes. That's the base palette that I just used for working. But the palette that Valis actually uses when he is in game is a palette called Default. Now, none of the color alignment changes. Just like in an earlier tutorial, the colors must be aligned, but the color values do. And now look. There we have the red tabard, the silver piping, the white breeches, the brown boots, etc. And this is what he would look like in game with his default palette. Now he also has some other palettes you can select from. Like when you start the game up, maybe you want to have a white color, so there is Valis White. And that changes the tabard to a white color with some red piping instead. But how do we get that blink effect? Well, let me go back and fix this palette to the default. And if you were paying attention while I was going through these, you probably noticed there is a blink palette, and that is how we do it. So there's the default palette, and here's the default blink. There is a white, and then there's a white blink. So the default blink palette, before I load it up, let's go back to the base palette here and close in on his eyes. Now the sclera and the, if I'm pronouncing that correctly, probably not, and his pupil are both independent colors from every other part of his body. So that sort of cream white, that is shared nowhere, and neither is the red. Well, Valis doesn't have red eyes, he has black eyes. So when the palette is loaded up, image mode, color table, load his standard palette, well then you get the black eye. But if we load up the blink palette, you'll notice the colors that make up his eye, we just change them to the same values as the second deepest flesh color. And that gives you the eye blink effect. It's really that simple. So all that we're doing in game is swapping the palettes. And it happens at regular intervals, set on a timing, which I'm going to show you in just a moment. And we've effectively doubled the number of sprites. It's like every sprite has an eye blink sprite, except we're only doing it at the cost of 768 bytes, which of course is minuscule. That's not even a kilobyte. That's less than a Word document. So how do we actually do this in game? Well, that requires a little bit of coding, so don't be scared. It's not a big deal. First, we go to Valis Jan himself. And if we look here, we can see some parameters that are set, and they're fairly self-explanatory. There's the H map, which I'll get back to in a second. The first is palette. Now this defines the palette that Valis loads and uses for his sprites when he is spawned into the game. So there we have palette, data, chars, Valis Jan, Valis default 0 ACT. And that is, of course, the palette that gets him the red tunic, the white breeches, and a partridge in a pear tree. Then the engine allows you to load an unlimited number of alternate palettes. So alternate pal, alternate pal, alternate pal, and these are all indexed as you go along. So palette will be your palette 0, alternate pal is palette 1, then palette 2, then palette 3. If you want to get really pedantic, the engine is using a 32-bit signed integer to track palettes. So you do have a palette limit. It is approximately 2.4 billion. Hope you don't run out. Anyway, back up to this H map. That stands for hidden map, and that defines 2 to 3. So the start range is 2, end range is 3, and that means that no palettes between start and end are selectable by the player. Now the engine can access them, script can access them, it just means you can't pick them on the selection screen. So I am able to select palette, the Valis default, I am able to select Valis White, but I can't select any of the blink palettes. So if we go back here to in the game, and on the selection screen you can see I can pick through the white and the red, but I can't select the green. Those are hidden from me. So all that remains is to automatically switch these in-game to get our blink effect. That's where our script comes in. So one more little thing we want to look at here is script. Now OpenBOR has dozens and dozens of events that will trigger and fire a script. Now right now, because we're very early in production, Valis only has script. That is the simplest of all the events. That occurs every single time the character is updated by the engine logic, which happens about about 200 frames per second, or 200 times per second. So 200 times per second, this script, event script C, runs. Let's go back here just to show it to you. Data, chars, valus, script, event C. So it's just sitting there right in his folder ready to go. Now when this script fires, it's going to run a function called main. And you put whatever code you want to execute inside of main. In this case, I am first getting the entity pointer that executed this script. In other words, that would be the pointer to valus itself. Void acting entity, get local var self. The engine provides that for us. Now I want to run my iBlink loop function. So DC iBlink loop, and then I pass it the acting entity. Now you could put all the iBlink functionality inside of main, but you generally, actually, let me rephrase that, you always want to break tasks down into individual functions and execute them accordingly, because that makes running your code like building Lego blocks. Now this iBlink loop depends on another function that I wrote called DCD20, and all that does, you don't have to worry about it because I'll provide it in the link, but that script allows you to generate a range of random numbers, which is what we will need to add a little bit of random factor to the timing. Now I'm going to walk right down through this and show you how everything works step by step. First thing, these defines, you don't have to worry about those a whole lot because you probably won't be writing this this type of bit shifting in your scripts, but that's okay. You don't have to have it. It's just a little something that I like to use to make things more efficient. So what we're doing is we're defining some masks here. This is an 8-bit mask, and then we have a 0-bit shift, an 8-bit shift, a 16-bit shift, and then a shift back to the 16th bit. Don't worry if that seems confusing. Again, this is not 100% necessary in your scripts. What is necessary is initializing all the variables you're going to use. So this is everything that we are going to need farther downstream in the script. Our blink expire time is the elapsed engine time when a currently running blink will stop. The next blink time is the elapsed engine time when we will start a blink. We have a flag because we need to know if we're currently blinking or not. We need to know how many pallets the entity has. We need to know what the entity's current pallet is. We need to know what our blinking pallet is. We need to know what the previous pallet was when we started blinking. Of course, we need to know the time elapsed to make time comparisons. And lastly, since I did the encoding I talked about, all of my blink data, in other words, the current pallet, the blink, and the old are all stored in a single encoded value that I call blink data. Now the first thing that we get from the engine to populate these variables is an OpenBOR variant called elapsed time. Now that is provided by the engine, and the way that works is every engine update, remember 200 times per second, this value is incremented by 1. So while the engine is running, that gives us an elapsed time roughly in centiseconds. So if it's 100, then we have 100 centiseconds, which would be 1 second. Then the pal current is the current pallet that the entity is actually using. Remember when I selected colors on Valus? Well, right here, since he's using his default palette, that would mean right at the moment he is on PAL 0. So that's what PAL current will show us. Now this next little bit here, I have detailed in a different tutorial, but this is essentially me using some bit shift tricks to compress all of that data into a single variable, and then I pull that variable and I'm able to decode it here. So get entity var just gets gets a variable that we have tied to the Valus entity, and it is labeled DC iBlink blink data, and that is an encoded value. Then this uses some bit shift tricks. Shift, to be clear, we're not using profanity here. to decode pal blink, pal old, and is blinking. And then we can start working with that data. We're going to move down here, and our next step, don't worry about these. These are log traces. That's just if you want to debug, it will put that data into the OpenBOR logs so you can see what's going on. I've got them commented out. Now, we check to see if we are currently blinking. That means Valis has got his eyes closed. He's blinking. All right, and the very next thing that we want to know is if it is time, sorry, my watch is going off, if it is time to stop blinking. So we are going to get our blink expire time that we stored previously, and then we're going to make sure that if that value does not exist, meaning say the first time this script is run, then we make sure that it is zeroed instead of a null. So we know that our blink time is 0, and so obviously then we need to stop blinking no matter what. Otherwise, if we were blinking, then this time would have been set to a certain increment before the current time, and once we reach that time, well, then we know to stop blinking, and that's right here. So if time elapsed, remember the current time right now is greater than or equal to our blink expire time, then we shut off the blinking effect. So the first thing that we're going to do is check the blink palette and compare it to the current palette. And if they are the same thing, in other words, if we are still on our blinking palette that we set up when we started blinking, we are going to change our palette back to the palette we had when the blink effect was first turned on. And the reason I make this check is because during the blinking effect, something else that we are not accounting for in this script might have changed that entity palette. Like we might have set him to a burn palette. He might be casting a spell and using palettes for special effects. Who knows what? And we don't want our blinking effect here to screw that up. So that's why we make sure that we are on the blinking palette before we change anything back. Now this next part here that comes afterwards, we will reset whether or not we actually stop our blink. And this is where we set up time for the next blink. So we take our random function and we give it a lower value of 250. So in other words, we are going to wait at least 250 centiseconds before our next blink. We set an upper range of 700, which means we are going to wait up to 700 centiseconds for our next blink. And then for our next blink time, we combine the time that has elapsed right now. So if the engine has been, if the level has been running for 100 centiseconds, we are going to add a random value between 250 and 700 to that. So if we are currently at 100 centiseconds and our random value comes up to 500, we are going to set our next blink time to 600 centiseconds, and then we will store that on the entity as an entity variable. And that is what gets checked up here. So that's how we know when to do our next blink effect. And the last thing that we're going to do since we're done blinking is we're going to set all of our blink data to 0 because we don't need any blink data if we're not blinking. Now, that is what would happen if we were currently blinking. Well, what if we're not blinking? Well, that's what this else right here is going to flag. So if we are not blinking, the first thing that we want to do is get our next blink time. And if that is not, if that does not have a value, we're going to set it to 0. Then we are going to see if it is time to blink or not. Now this works the exact same way as the finishing the blink. So we look at our current time elapsed, and if our current time elapsed is at, or is greater than or equal to the next blink time, then we know it's time to blink. Now this right here explains how that I did the palettes, because this is the formula that the blinking actually uses to get the correct palette. If we go back over to Valis here, we'll see that the way I set this up is we have all of the standard palettes, and then we have the blinking versions thereafter. And this just simplifies things for palette selection. So what the script does is some simple math in that we divide the number of pallets that are available, and then we add that as an index. So we know that since we have 4 pallets, then whatever pallet we're on, we need to move up by 2. So if we are on pallet 0, then we need to increment by 2, and that gets us to pallet 2. So 0, 1, 2. And if we happen to be on pallet 1, well then we increment 2 to get pallet 3. So that makes sure that it matches. So our default pallet goes to our default blinking pallet. So pallet count, we get the number of pallets that are available, and then we divide that by 2. I'm doing that with a bit shift, but it is the same thing. It would look like this if we're doing a straight up divide. I would say pal current equals pal count plus equals, in other words, take pal current and add the value that we get from dividing pal count by 2. The reason we do that bit shift instead of a direct divide is that shifting a bit by 1 is effectively a division by 2, and it is also immune to a divide 0 errors. Plus, it's faster than a divide. Now, once we have done that, then we apply that pallet to the entity. So change entity property, our target acting entity, its map property to the pallet blink that we calculated. So this is what changes Valus from his red pallet to his red blinking pallet, or his white pallet to his white blinking pallet. Then we populate our isBlinking variable with a 1. That just means that it's true. And then we set up the time for our blink duration. Now, our blink duration, of course, is going to be much shorter than the time between blinks. So 15 seconds to 45, 15 centiseconds to 45 centiseconds. We take that, we pick a random we pick a random value between that 15 and 45. We add it to the current time elapsed. That is the time that we will expire, in other words, to stop blinking in our check above, and we set that to our entity variable as a blink expire time. And then, because we need to know the blinking pallet, the old pallet that we had when we started blinking, and if we're blinking or not, we use some bit shifts to encode all of that into a single value. Again, you don't have to do that. You could just have a separate entity var for each one of those. I just like to encode them. So anyway, we have them all encoded to a single value. We store it as an entity var, and we are done. We undefine our constants, and then everything cycles again. So this runs 200 times per second, and when it detects proper timing, it sets up the pallets, it executes them, and we get a blinking effect that is completely independent of Valus's actions. And there you have it, an organic eye blinking effect. Now, it's not the greatest effect in the world, but I think that lots of little things like this add up, and that's what gives a character a very organic feel and less of a, I guess, video gamey feel. Anyway, everyone, I hope that has been helpful to those who asked that question. I hope it has answered your question. I will leave links to some of the scripts in question, and if there is anything else you need, just hit me up on the forum. As always, I'll leave a link to it as well. Everyone, thanks for listening, and we'll see you next time.